Hello everyone and welcome to Chapter 10 of the eggPlant Performance tutorial series. In this chapter we're going to delve deeper into generation rules, and this will be part 3 where we'll be discussing data correlation. So correlation is a topic that most performance testers will be very familiar with. It is that process of taking a dynamically generated value that the server sends to the client in a response and ensuring that that value is used rather than any kind of hard-coded values that might have ended up in the script as a result of that script being generated from a recording. So it'll sort of deviate a bit from where we left off at the last chapter. There were some problems with the generation rule for verifying that the login succeeded correctly. We'll pick that up again when we get to the point of running with multiple virtual users, but for now we'll just continue having a look at generation rules. So with data correlation, there's typically two different types of values that you would want to perform correlation on, and those tend to fall into one of two categories. So the values are either going to be session related or some kind of unique identifiers. So session related basically means it's got something to do with that user's session, as you might have guessed. So HTTP, the protocol itself, is a stateless protocol. That means there aren't really any built-in mechanisms to keep track of who is connected to the web server. And so there's usually a need to create some kind of state mechanism. And that's usually done in cookies, but it can be done in lots of different ways, depending on which web stack or application that you're dealing with. And if you don't handle them properly, what typically happens is you'll either get an error page or you'll be redirected to the login screen. It'll appear as if you're a not logged in user, essentially. Unique identifiers, on the other hand, tend to represent objects. And so objects, that's a pretty broad term, but it'll encompass things like documents or customer or patient records, product IDs, anything in that kind of a category. And when you store an object on a database, it usually has some kind of a primary key or a unique identifier, which is what the application itself uses to keep track of what product it is dealing with. And so these unique identifiers will often end up hard-coded in the script, and that's a problem because those values may change whenever the application changes in some way. For example, two common scenarios where those identifiers change is when the application has been upgraded, so there's been a version drop, some code is changed, but that might have also instigated other things changing, such as those database primary key IDs. And of course, if you're switching between different environments, they're more than likely pointing at different databases, and the IDs, the primary keys, will often not match. And so it makes sense to then need to correlate those values. Data correlation is going to be something we'll need to bear in mind with what we're intending to do as part of this session, which is to create a search script. So a script that's able to search the Nopcomer's website for different products to then be able to add them to the cart. So the first step is just to record that search transaction and generate a script from it. The second step will be to modify that script so that you can specify whichever search keyword you like. So you might want to be able to perform a search for book or camera or something like that. You want to be able to change that in order to put some pressure on whatever functionality is providing the search results. If you're just specifying the same search keyword each time, chances are that the server will have cached that result set, and it is therefore able to deliver that search result much quicker than if it actually has to go to the database to find out what products are actually available. So as far as generating realistic load is concerned, that step is quite important. Number 3 could be considered optional. You may or may not want to include keywords in your data that actually don't result in any search matches. Usually you'll want to perform searches that reflect real user activity, and it could very well be that real users type in searches for things that don't actually exist in your catalog. But anyway, that's not something we want to do. We're going to try to make sure that all of our searches are giving some kind of results back to then interact with further. So we'll want to put in a little check to make sure that if there are no search results, that we know about it straight away, rather than having the script fail when you then try to add an item to the cart that doesn't exist. And the fourth step then is to pick a search result, regardless of which keyword was used to conduct the search. So if I search for book, I just want to select the first search result that gets returned. You can make that logic more advanced by having it select at random from the list of search results returned. That's a topic for another session. We'll just keep it simple for now, and we'll want to just select the first search result. Okay, let's start with creating the recording. So the process is exactly the same as before when we created the test recording. Just now I'm going to call this a search recording. Still using the web proxy recorder. I just have to hit next. Now I've added an option here, a command line argument, specifying that I want to launch Chrome in incognito mode. So all browsers these days can be launched in this incognito or private mode, and that's basically going to ensure that you are visiting the site as a completely new user. There won't be any cookies already in the cache, and there won't be any cached images either. And so that's desirable from a performance testing point of view, because you want to appear as that new user to ensure that everything will end up in the script. So if there's already a cookie in your browser, you might already automatically log on as a result of that, and so you wouldn't want to do that, because then your script will probably not work when you suddenly change to or wanting to use a different user. So launching in incognito is something we're going to be adding as a feature in an upcoming version of eggPlant Performance. But for now, you can still launch it in incognito mode by just passing the appropriate command line argument. So that's all I've done here. Everything else is the same, and just start recording there, and you'll notice that this is that incognito session that's launched now. As before, it's always a good idea to annotate your transactions. So the first one is just going to be browsing to the home page. There's our URL, and there's our home page. Now the search is actually already here, so I can already start performing the search transaction, even though I haven't logged in yet. So it doesn't actually matter whether or not I'm logged in this case. My ability to perform a search isn't impeded, so I should just be able to do it straight away. I do want to search for something that exists, because I'm also then going to try and open a search result, or the first search result, and so I do need to use something that results in at least one search result. There we go, there's our camera, so I'm just going to open product. It's not a camera that I'll be opening with this script. Were we to search for something else, so it's good to give it a generic name there. And that's it. That's all I'm going to do in this case. It's just the search script, nothing else, so I can stop the recording. There we go, recording's complete. It's remembered the setting here for the whitelist of knobcommerce.testplant.com. And now we're going to generate a script. It's going to be in C#, just like my other C# scripts here. It's going to use the knobcommerce VU, for which we've already created some generation rules for. So this recording will inherit those generation rules. Now this is where we can split out that recording into multiple scripts. But in this case, what I actually want to do is exclude a bunch of transactions and not put those in any script at all, because we already have a script that does the browse to homepage step. The search script will only really concern itself with the actual submission of the search, as well as the opening of one of the search results then. That's the extent of the search script. Here we see the nopCommerce VU, which is the custom virtual user that we created earlier. There's the three rules that were created for the login script. They're visible here because we're using the same VU. But we probably won't see them activate because they're all dealing with things that we found in the login script, and so they should just not apply to the recording, and we should see that shortly when we generate the script. Okay, that's now completed, and we can see that no requests met the rule criteria here for our custom VU rules. That's fine. Let's have a quick look at the script. May as well do it in the IDE. Okay, here it is. All right. So, okay, here's our script method, which will contain the actions or the transactions that the script will be performing. So the first one is submit search, and the second action is select product. So submit search, it seems it actually consists of two requests. The first one here is to search term autocomplete. So as it happens, the website, as you're typing in your search term in the search box, it fires off an AJAX request, an asynchronous JavaScript HTTP request. Basically, it's giving you a little preview window when you're submitting your search that lets you see, if it's already able to find the thing you're looking for before you actually go ahead and browse to the actual site, or before you actually explicitly carry out the search transaction. So that's why you actually see two requests in here. Were I to have typed the camera out slower, then there might be more than one. And so at some point you need to ask the question, how do I want my virtual users to simulate this? Is it safe to assume that each user in the real world will cause three of these requests to happen for each search they carry out? Those kinds of questions may or may not be important in the grand scheme of things. It certainly depends heavily on how many users you expect to visit your site, and also how many users your servers support. And the second action here, selecting the product, we actually see that the request that we're making is going to a very specific page for this Leica T mirrorless digital camera. So this is the thing that we're wanting to perform correlation on. So we're no longer going to be interested in selecting the camera product each and every time the script iterates. We're going to change the search that we do, which is actually done with a replace key value rule. We're going to change the search, so we'll get different search results. This camera won't even be there as a search result unless we search for camera, and so we need to select a different URL from the response that we get from submitting the search. So that's where we'll do the data correlation. We're going to modify this URL so that it goes to the URL belonging to the first product in the list. So the normal process for doing that is just to select the value you're wanting to parameterize in its entirety like this, and just copy it to the clipboard is usually the easiest. So it's now on the clipboard. I can go into eggPlant Performance, click on Regenerate, which is how I access the generation rules here. I can hit the Script Assistant button here. Generation Rules Assistant is able to tell me where a value came from. Was it from the server, or was it something input on the client, or something generated by JavaScript? So if I hit the Analyze button here, it'll tell me that the text originated on the server, and if the text will be different each time the script is executed, then it will need to be correlated. So I'm expecting it to be different. We're going to be selecting a different search result, and so I'm not expecting to see this all the time. It needs to be correlated. And so we see it actually is present in several requests in the data that we send to the server. That's not really of interest. It's more where we actually receive the response. So we know that request 41 is going to contain the value because that's the search request. The question is, where did we first see that camera string appear from the server? And it was actually during the search term autocomplete as well as the search itself. So in both cases, we were able to find a link or some kind of a URL fragment for that search result. But the actual one we want to extract this from, because we know we're going to the search page, is probably this search page, request 36. So it's highlighted where the value was found, and now we basically just proceed to the next step. This is really just an information screen where you can see where the values appeared. Once you've figured that out, you can go to the next screen. We now gray out all the other rules that we've identified as not being relevant in this case, and we've instead recommended the data correlation rule. This little diagram here basically shows what the process involves. So we're getting some dynamic value from the server. We'll want to store this value in the virtual user's data dictionary so that we can then use it in subsequent requests going forward. And that's basically what correlation is all about. So the data correlation wizard will actually suggest what are known as the left and right boundaries or left and right strings around the value that you're wanting to extract. So this is what we identified as being the value we wanted to extract to begin with, and so the engine has worked out that in order to extract that value, I should use these left and right boundaries. Usually, you only need a single character for the right boundary. I think I'm just going to knock all of that off. But as a result of doing that, that might have modified things in such a way that there's multiple hits for what I was originally wanting to extract, so that we're now extracting different things. So you can see what would be extracted with this left and right boundary combination. And it's actually a bunch of different results, but you'll notice that they are for different requests. So the search request is number 36. We can just verify that by going into the recording. This is when the search was actually carried out, and we got the search results back in somewhere in this HTML. And so really we don't want to perform the extract here, but given these left and right boundaries, the rule would trigger there as well. So there's two ways we can do this. We can make the left boundary more unique so that it only triggers for request 36, or we just put a filter on later on in the next stage of the wizard. You can filter out so that the rule only applies to certain requests. In this case, I think it's safe to add another left boundary here. So this dialog actually allows you to put several items separated by a line, and what happens when you do that is that we'll search for the first sequence of characters and then any number of characters. So we see that this is not colored in any way. It means we're just skipping ahead of that and allowing any characters up until this next sequence. Both sequences do need to appear. In fact, all three of these need to appear for the left boundary to trigger, but they're separated, so there can be other things after each one of these items in the list on the left. That's why we're still able to find the match here. Unfortunately, it's still triggering on the very first request response, so it looks like we'll probably need to do the filter after all. But that's pretty simple to do. We just filter on the search URL in there to distinguish it from the base path to the site, which doesn't have any kind of query data or anything at all. Okay, so I'm just going to go to the next screen now. When you perform an extract of a value from a server, that the value that gets extracted needs to be stored in a variable, and this is where you get to pick a variable name. So product URL seems like it would make sense to use there, so I'm also going to write that value out. So $variable is a special macro that'll expand out to allow us to write this product URL. We'll see what that looks like in the generated script in a moment. And this is where we can filter that rule to just apply to particular requests. So I don't want to extract wherever that left and right boundary appears. I just want to extract on the search URL. So we still have another one in there. Looks like we can probably add the question mark. This is a regular expression. The question mark is a special character, so that just the leading forward slash there just escapes it. Okay, and that's it. Alright, let's see how that's changed the script. We'll discard the previous versions of these files and load the fresh script now. So straight away we can see some stuff on the screen here. So this is the correlation rule kicking in, and it's performing the actual extraction here. So you see response 36.extract. Extract is the API call. You'll notice there's plenty of overloads for the extract method. There's various different ways of performing an extract, and this is why there's a wizard around it. You know, it's doing some pretty intelligent stuff. The wizard needs to keep track of where in the response it is in case it needs to perform multiple extractions, and yeah, various other options. I won't go into them now. You can of course see the documentation, the API documentation, to get a full list of what all of these different overloads are. So if you manage to extract something from that response, we'll print out the product URL, and the API call is for that to access that variable is getString. So this is using the virtual user's data dictionary to store that value using setString here, and the equivalent for getting that string out is this bit of code here. So what that's also done, so the extract is one part of the rule. The second part is to actually make the replacements wherever the original value appeared, and that was in this URL statement over here, or URL declaration. So we're no longer going to this Leica T mirrorless digital camera URL. We're instead going to go to whichever is the first search result in the script. Of course, we're still searching for camera. We haven't modified the search term yet, so that's probably a good next step. So we'll repeat the process again, but this time for a replace key value rule. Okay. We know exactly which rule we want, so I'm just going to go ahead and press the add button there. It's this replace key value rule we're interested in. Same again with the data correlation rule. You just type in the value that you want to parameterize. And now it does appear in two places. This is expected. Here, camera is being added as query data with a key value of term, whereas in the actual search request itself, it's being added to a form with a key value of Q. And so that's why we see both of these keys there. We want to parameterize both, of course, and so we just select both and bring them across. And we'll probably want to take this value from a data dictionary, and let's call the key search term. So we'll still need to create that data in order to make some new search terms available to the script. Okay, let's create the data source. There'll be a data table file because we have a one-to-many relationship there. Just call it search terms. Double click to open. And the key name has to match what we just defined in the generation rule. So search term even with a capital T. And to have exactly the same as what we had before, you could just add in camera over there. I'm actually not sure what other things are available here, so let me quickly go and have a look. Alright, there we go. We've got some more search terms now. And the last step is to make those search terms available to the search script in our test. So we'll go to the basic test that's running the basic workflow. We need to modify the basic workflow so that we're now also performing a search. I will put that after the login there. Go back to our test definition here. Now, the data that we're using here in this data table file, we want to have a bit more control over how that data is accessed. So we're not going to link it at the test level. We don't necessarily want one row per virtual user. Instead, we actually want all the rows in the file to be available to all the virtual users, and that's why we're going into the virtual user group in order to get to the data sources setting page in here. So if I add my search term data table through this location, we get this dialog here, which gives a lot more control. So I'm going to make all the rows in this table available to all of the virtual users. If I didn't have this recycle setting checked, then I would be warned here that there's just not enough rows in this data file to satisfy the needs of all the virtual users. Recycle rows basically means we go back up to the front of the row, or the top of the table, in order to then cycle through all of the available rows again. So recycling is, in this case, is important. We don't actually want to select in order from the allocated rows. We just want to randomize the access policy for the search terms in the data file. And again, we're just going to pick and then replace the rows that we just picked straight away. So we're basically just going to repeatedly take at random from that file. And the row will advance, or the next random value from the data table will change on each iteration, which is the default there. So this should ensure that all our virtual users are just picking at random from the 10 search terms that are available. Okay, now I can just hit save, and we can run this test now. We can run it with just a single virtual user in debug mode. Let's go ahead and do that now. Okay, and just gonna go ahead and hit F5. Okay, there's our web log along with the event log. Alright, there we go. So we've successfully logged in as email01@test.com. We've performed a search. We didn't output what kind of search we were performing. You can see it here though. We were searching for a book in this case, and the first product URL that we encountered was Apple MacBook Pro 13-inch, which is the page we're browsing to here. Now there is a warning being output here, and that is a warning about the HTML title being unexpected. So we're expecting, or the script is expecting, to encounter this camera title, but instead, because we picked a different product, we're seeing the Apple MacBook Pro title. So we need to override the behavior of the verify title rule for this particular request. So we probably still want to perform the verify title check against the other HTML pages that we're seeing. So I don't really want to just disable it. Instead, I'm just going to override the one for the request that we're interested in. And what I want to do is to actually look up what the page title should be based on some more test data that I'll feed into this script. So this will be the expected title. We'll have to create this field. It'll make sense to put it in the search terms data file as well, because there is that one-to-one link with the actual search term being carried out. And I don't really want to output anything in particular beyond the default warning there. So I'm just going to skip ahead and click next. And I only want to apply this rule to the request in the recording that corresponded to the actual search result page when we actually opened up the search results. So in this case, let me just go back out here into the recording. That'll have been this particular request here. I could just use the 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 name that I search for here, but then it wouldn't be a very generic rule. Instead, I'll look for this referrer header to exist. I think this one will be the only one with this referrer. So I'm just going to add it in here. Be a request header that we're looking for, and the header will be referrer. Stick that in there. I think it's also applying to a JPEG that doesn't even contain any HTML, and so this rule shouldn't eventually apply to this either. It's just a filter that's showing up there. And just hit next and generate. Okay, that's done. So we see that's applied to request 41. Let's go back into our script again. Okay, so here we see the search term replacement being done here now. Also down here, the same again with just get string there. And the replacement here of the parameterization or the correlation. And then here is that custom verify title rule. So we're just going to do a lookup on the expected title there. The last thing to do is to update the search terms now. I'm going to add another column here for the expected title. Okay, that's our expected titles in there now. We can just switch back to Visual Studio and run this again. Hopefully we'll no longer see that page title warning. So we're again searching for that Apple MacBook Pro, and this time there's no warning, so presumably it's found the correct page title. Okay, let's review progress so far. So we've performed step number 1, record the search transaction and generate a script. We've modified it so that we can search for different items in the catalog. We haven't yet outputted a warning when there are no search results, but we have picked a search result regardless of which keyword was used as well. So the only step that's left is number 3. Let's go ahead and make that change now. So the easiest way to handle this is to modify the correlation rule. So when the correlation rule fails, that's more than likely going to happen when there are no search results to pick. We can insert some code here that'll execute when that failure condition happens. So there are some built-in options here that you can use. For example, you can just generate a warning message and continue. We probably actually want to perform a combination of these. We actually want to output a warning and then move the user on to the next iteration so that they can then search with a different search term, perhaps. So I'm just going to type that out manually here so you see some more of what that code looks like. So this is going to be a simple warning message, no search results found, and then the API to go to the next iteration is literally just next iteration. So that's pretty much it. Again, we just regenerate the script. Hit finish. If we go back to our script now, we should see the corresponding code for that. And it is actually when we're performing the search. So this is the code that was added. And that's pretty much it. That's an example of data correlation, as well as making a script useful in the sense that you can change the inputs in order to stress the server in different ways by ensuring that you're not always searching for the same thing, which risks you fetching a cached result instead of something that the server actually has to do some work for. We'll probably encounter many more examples as we continue the series, so make sure to look out for those if you'd like to have a more advanced look at correlation. I hope you enjoyed the video. Stay tuned for the next one. Bye bye.